Water is life, and without water we cannot survive.
Although water is abundant, only about 2.5% of the global water exists as fresh water. The rest of it is locked up in glaciers, ice caps, and groundwater, and actually only less than 1% of fresh water is readily accessible through lakes and rivers. Water is a very precious resource because we need it to survive, but it is becoming increasingly scarce due to high water demands. We are more likely to run out of water than we are to run out of oil at the moment. And in fact, water scarcity is a bigger environmental issue than climate change at the moment. The global water threat had been highlighted by the US intelligence. It states that risk to fresh water supplies due to shortages, poor quality, flood, and climate change are growing, which will hinder the ability of countries to produce food and energy, and potentially undermines potential food markets and economic growth. By 2030, global water demand is forecasted to exceed the supply by 40%, so there is an urgent need to solve the global water crisis at the moment. To try to solve the global water crisis, we first try to identify the main consumers of water. So who are they, and are they using water wisely? This chart shows the global water consumption by different sectors. Here it is obvious that agriculture sector takes up about 70% of the global freshwater consumption. Traditional methods of agriculture is inefficient and wasteful. It results in massive loss of water due to transpiration, evaporation from water runoff, and even some of the water that's been used to irrigate the soil seeps in so deep that water is not used to grow the crops and instead is used to recharge the groundwater instead. So according to the International Water Management Institute, there is insufficient water to continue farming using traditional methods. Thus, we reason that by revolutionizing traditional irrigation methods, it would have a large and immediate impact on the global water crisis. In the next section of the talk, we will introduce a solution that has the capacity to save up to 90% of water from irrigation.
Vertical farming is a well-developed indoor farming technology, which usually means we cultivate crops and animals in a skyscraper greenhouse. However, the large scale of the traditional vertical farm results in tremendous investment and difficulty during operation, both technically and financially. The technique provided by vertical farm systems builds the multi-level growing system small enough to fit in warehouses, which makes it more accessible and widely spread. The vertical farm is consisting of two main parts, a climate cell and a processing bench. The bench system including robotic seeding, automated harvesting, and loading transporting functions. The crops will first seed outside and transport into the climate cell. The growing condition inside the climate cell is fully controlled and enclosed. The bioponic nutrient growing media and enclosed system make sure no pesticide and harmful chemicals in the crops. Well-designed LED lighting system ensures minimum power usage for maximum plant growth and reduces energy usage for climate control. Especially, a plant transpiration recovery module integrated into the growing system greatly reduces total water consumption. The crops will be harvested after 2 to 3 weeks growing, and the growing media needs washing for the repeating use. The total water usage, including growing and washing media, in the vertical farm is only 10% of that in traditional open field farming and around 20% less than conventional hydroponics. Moreover, the system also produces additional water by stripping humidity from the ambient air when relative humidity is about 35%. This enables the system to operate without any outside water source in many parts of the world. The main energy usage in this system is from the LED lighting, and this usage will increase dramatically, which is proportional to the crop growing periods. So we can use high-efficient LEDs to save the energy. Moreover, we should find more energy suppliers. We can not only build up solar cell systems as additional electricity sources, but converting agricultural waste to biofuel to make full use of crops in the vertical farm. This vertical farming system is only used for growing green leafy vegetables by now, but it has the potential to cultivate all kinds of crops. Once we develop systems proper for wider use, we will save up to 90% water used in the agriculture.
Next, I will talk about the economic analysis and the potential profitability of a vertical farming system. Here is a flowchart of our analysis. We first target the demand of vertical farming. Second, we compare vertical and traditional farming system in terms of financial returns. Lastly, we propose potential financing methods. According to a report on healthy eating, every year each person needs to take 146 kilo vegetable. Considering that the population for a large city could reach several million, there will be large demands and markets for vertical farming systems around large cities. When estimating returns for vertical and traditional farming systems, we have two major assumptions. First, according to the information from our technology providers, the payback period varies from 2 to 5 years. We use 5 years for a conservative estimation of returns. On the other hand, we assume that the annual gross return for traditional farming is 11.9%, which is an upper bound. Because vertical and traditional farming have different project life cycles, we use equivalent annual value to compare the two. We found out EVA for vertical farming is 12.1% higher. This figure provides detailed comparison between vertical and traditional farming. It's from the case study where the initial investment to vertical farming is $2 million and the life cycle is 20 years. At about year 13, the cumulative return of vertical farming catches up with traditional farming. The figure has demonstrated the profitability of vertical farming. However, the initial cost is large. Farmers may not be willing to or afford the shifting from traditional to vertical farming. There are two major funding sources for solving this problem. First, we propose to attract venture funds and even to establish high-tech companies so that they can share the risk with farmers. Of course, they will also split the 20% annual return, which is still higher than the return achieved by a mutual fund. Second, vertical farming can seek supports from government and non-profit organizations. With their support, farmers and investors are more willing to implement this new system.
Okay, I'll talk about environmental benefits of vertical farming. There's already a widespread and growing awareness that current agricultural practices are unsustainable. In a nutshell, vertical farms offers an ideal solution, particularly in the case of climate cell technology, which stringently controls the relatively minimal water consumed. Vertical farming has several distinct advantages, securing environmental benefits. Most importantly, vertical farms reduce water use for crop irrigation by an estimated 80 to 90%. This removes the demand on scarce water resources, including rainfall, aquifers or groundwater, rivers and springs. The advantages of vertical farms are numerous and include the possibility of year-round crop production so that you can escape from drought conditions, an easy way to increase accessible food supplies for growing populations, elimination of toxic agricultural runoff and water waste, a climate-controlled growing environment that reduces weather-related crop failures. The confined growing space permits reclamation and restoration of former horizontal farmland areas to become natural ecosystems, therefore protecting natural wildlife and flora. The reduction of pests and plant diseases eliminates the use of chemicals, pesticides and fungicides, and makes it easy to grow pesticide-free products. Significantly lowers fossil fuels and food miles. It's adaptable for abandoned or unused buildings. The energy use is readily augmented by solar or wind installations on site. The work of vertical farming is less heavy, toxic and dangerous compared to traditional farm work. It offers the possibility of cultivating biofuels, industrial hemp, and plants supplying constituents for medicinal drugs. Overall, vertical farming is a sustainable, ecologically sound solution that at the present time is appropriate for densely populated urban zones. Recent vertical farming technological innovations have made intensive farming possible not only in urban spaces. Beyond urban zones, climate cell style vertical farms can innovatively address the food shortages and health problems of remote places where food is costly to purchase due to distance and low income, is problematic to grow due to climate and environment, and quality nutrition in these places would be extremely helpful to prevent chronic disease problems frequent among remote Aboriginal populations. Australian governments may be interested in investing in this technology to promote the health and social well-being and the skills training and social participation of selected communities. Developing countries and arid regions may similarly benefit from vertical farming to help nutrition and food supply problems.
This book, The Operating Manual for Spaceship Earth, written by one of the most profound thinkers in the 1960s, named Fuller, in it mentioned that the overpopulation of the human species would lead to insufficient water, food, and energy. And unless we make some tremendous technological advancements to tackle these issues, the humans are at risk of extinction. We believe in vertical farming because it has many benefits. For example, it can reduce the water usage in agriculture by 90%. It can increase food production. It allows the ecosystem to repair just by using less land. And it is also highly profitable. This high-tech way is the way of the future.